Thank you. Just great. Thank you, Srisha. And thank you, Lakshmi.
Thank you, sir.
Thank you, Lakshmi. Lakshmi, I will try to catch up with you today. And I will try to catch up with you today. Sorry, I couldn't get back yesterday. Sorry about that again.
Okay, no problems. I can understand. Yeah. Sure. Have a good day, everyone.
Thank you, Lakshmi. Okay, guys. So sharing my screen, and there you go. Let me share this. I'm going to share everything. Screen, okay, there you go. Share everything. Okay. So let's see, gentlemen, ladies, just a quick and friendly review. Continue the journey on Python, and let's see. Before I get started, let me come back here, back to the team intro. Let's take a few more introductions, guys, just as part of the discipline and knowing a little bit about each other and things like that. We will just, so we had a few of them, Aniket, Kajal, Lakshmi, yes, we all know, Moin, Nitesh, Rahul. Let's see, Humera, are you there? Can you just give a, can you come online, give a quick and a brief introduction about yourself, please?
Hello, good morning. I'm Humera Khan. I joined NSCIT as a fresher as well, and I've completed almost a year in cloud. I'm working with COE as a technical analyst. And yeah, looking forward to this training.
Wonderful. Thank you, Humera. And let's see, Kajal, I think she introduced, she's Kajal Yadav. Let's move on to Shraddha Wagukar. Shraddha, are you there?
Yeah.
Go ahead.
Good morning. My name is Shraddha Wagukar. So yesterday I completed 1 year in this organization, and currently I work as a technical analyst in the COE department. So looking forward to this training. Thank you.
Wonderful. So what do you guys do as tech analyst, if you don't mind me asking you? Just curious. Shraddha or maybe Humera, what are you guys doing as tech analyst? Are you into data analytics and things like that?
I need to involve my network team to go ahead and do that. Okay.
Not really, not into data analytics.
Okay, so not much into data analytics. Okay, that's cool. Thanks. Let's see, Shraddha Shri Shel, the boy, come up. This is a boy who wanted to marry a girl who's rich, isn't the rich girl's man.
No. That wasn't me. No, that wasn't me.
Okay, buddy.
The rich was a different fellow. Yeah, so it's GUPTE.
Okay.
Yeah. So my name is Rishal Gupte, and
okay.
I am a computer engineer by qualification, and this is my first job.
Oh.
Even I'm close to complete 1 year as a tech analyst in this company NSCIT. So as a tech analyst, it's just an on-paper position is trainee associate system analyst. But since we are placed in the ICSCOE, which is infrastructure cloud services, we basically deal with when clients come up with the proposal for migration of on-premise to cloud. We get involved in making of the architectures, BOMs, bill of materials, and then we deploy by considering the BOM and architectures on the proposed CSP, cloud service provider, which would be either AWS, Azure, or I also deal with Openstack as a private cloud. And we carry on POCs, which is proof of concepts, and do research on these fields. That's our job as a tech analyst. And we have 4 tech leads, which guide us through this one. Thanks a lot.
Wonderful, Shri said. That is good one, buddy. You explained almost everything there, and that is very good. I appreciate that. Let's see, move on to Sumit. Are you there, buddy?
Yeah, hi, good morning.
Hey. Talk to me about it.
My name is Sumit. Yeah, I'm working as a tech lead for AI Ops here. So one of the pillars of COE, wherein we take care of the monitoring and APM infrastructure monitoring or full stack monitoring activities. So I have about 5 years of experience in this domain, and we are still trying to develop a full-fledged solution provider for the complete AIOps platform. So talking about that ELK that we are right now using, we'll be using a New Relic as well that the training is scheduled for. And apart from that, other tools we are going to use for the complete solution. Yeah.
Wonderful, wonderful. So you guys are already into AI, Sumit?
Yes. Means,
Oh.
we are actually doing infrastructure monitoring and APM, but we are still to explore the machine learning and big data so that we can apply big data models um, to learn complete AI models, and we can say to use the or utilize the AIOps platforms which are there. We have just partially used that, but we wanted to use for a full use of that.
I see. Very good to know. So
Yep.
that's when all the money is today, Sumit. The machine learning, the big data, and the deep learning. This is where most of the clients are putting the money into, and they're trying to get the magic out of that. And these things, I'm a rock star, buddy. You can feel free to let me know if you have any questions and things like that. Hopefully, I'll be able to get some good knowledge across to you in the areas of ELK and New Relic, and hopefully, I'll be able to give you some satisfaction in that, buddy. Okay?
Yeah, sure.
Very good. And let's see. Sai, are you there, buddy?
Yeah.
Go ahead.
Hi, sorry. My name is Sayar Gai. I have EXC engineer. I have completed 2.5 years in NSAIT as I have recently joined this team. 2.5 years.
2.5.
By qualification, I am a EXC engineer, and I have completed this 2.5 years. So previously, I was in desktop support. Then afterwards, I have completed some cloud-related courses. Now I am a engineer. I just want to explore this cloud thing. Willing to learn some cloud related or any programming language. I have also basics of the Linux.
Very good.
Thank you.
Sounds good. Thank you. Okay, so I guess I think we covered everything, everybody here. And let's see, Nitish, we covered yesterday. Moin is covered, Kajal is covered, Rahul is covered, Sai, Shraddha, Shrisel, and Sumit. Okay, thank you guys. I won't take much of your time. That's just a little bit of friendly knowing about each other and things like that. And let's get back to a little bit of action, guys. Okay, so come back here. Gentlemen, ladies, so just a quick and a friendly review of Python and the things like that. If you recall, Python, there's my favorite quote and saying. Just a quick this thing. I always like to look at that. It really touches me a lot. So just quick this thing, but let me move on. So gentlemen, ladies, we discussed briefly about Python. And remember, Python is a very high level dynamic programming language. We say it very high level because it has lots of packages and modules, and we end up writing a lot lesser code. In other words, short and sweet, the friendly mantra of Python is the engine of a car. Python is like a cricket game. And we play this game in a playground. The playground is Jupyter. The friendly mantra of Jupyter is web IDE. I'm sorry. The friendly mantra of Jupyter is the playground. The technical mantra is it's a web IDE. Okay, for everything there's going to be a friendly mantra and a technical mantra, guys. And then comes Anaconda. Anaconda is the stadium. In a stadium, there are a lot of games being played. Jupyter is one of the playground where a lot of games can be played. And our game is we'll start with Python because Python is becoming the go-to language, the modern go-to language for anything and everything and so on, guys. Okay, this will help you get a lot of interesting perspectives, and it will make things very easy in the coming up days working with other tools and technologies. So that is a little bit about Python we discussed. Then we were exploring the Jupyter. Oh, look, let me see, bring this up. Here we go. Okay. We did a few basic arithmetic calculations. The objective is to understand that we can use Python for very simple operations like calculator. In the later days, if time permits, I'll also give you a touch of maybe a little bit of machine learning in AI ops and things like that. And that is where Python can not only be used as a calculator, it can be used as a cycle, as a scooter, as a car, or a helicopter and rocket. Helicopter is the machine learning part of it. Rockets is the deep learning part of it. That's more advanced. That's a little bit about Python. So we started with some basic operations, guys, okay? By any chance, do any of you remember what is teacups that we discussed, guys? What is the meaning of teacups? Can you quickly type in the chat window? What do you think is teacups? Okay, so teacups is numeric data. What is coffee cups, guys? Good, it is textual data. The friendly mantra is coffee cups. The technical mantra is textual data, or more precisely strings in a programming language word. So tea and coffee. By any chance, do you remember what is green tea? See if you can quickly type in the chat window. The hint is on the screen. It is integers. Integers are non-decimals. What is ginger tea? Ginger tea is float. Float is decimals. As simple as that. Remember, all green teas are tea, but all teas are not green tea. Same as with all ginger teas are tea, but all teas are not ginger tea. All decimals and non-decimals, they are numeric data. Numeric data is tea, but all numeric data need not be decimals or need not be non-decimals. Something to keep in mind, guys, okay? So let's say there is a textual data that is a string. The string is nothing but the coffee cups. Then we discussed about single quotes, double quotes. When you have multi-line, we use triple quotes. And print is used for printing, as the name suggests. It is slightly, it's kind of removing the special characters. It's printing the special characters, guys. As simple as that. It's a slightly more prettier print than when we don't use a print. If you don't use a print, the last line is overwriting everything, guys. If you use a print, everything is getting printed in a separate line. So let's see. Let me come back here and let's see who else. Sumit, since you're the tech lead, buddy, can you try to maybe open up? I need a G drive or some kind of a drive where I can upload some of the things for you. Do you think you can pursue that and get that for me? Sumit, are you there? If you cannot do, I will open a G drive and I'll share all my content. But if you are there, I need you to go ahead and, are you there, Sumit? How about others, guys? Within your company, generally when I with other companies, they open up a G drive or some kind of a drive and they give me access where I can upload all my content. So I'm just checking with you. And I also need the AWS access. I was earlier talking to Nirnoy and he said he'll send it my way. But just in case, if any of you have any idea about it. Okay, no problem, guys. I'll get back on that. Let me come back here. Okay, so there is the print. We discussed about the print. And there is coffee, the textual data using the single quotes and double quotes. If you want to put single quotes or double quotes in between, a better thing is to use a triple quote. That will allow you to put a combination of single quote and double quote. Okay, guys. Then there comes the multi-line text. Single quote and double quote will not work there. That's where the triple quotes come to your rescue. Okay, print again is slightly prettifying it and printing it. Then we talked about objects. Objects are like the cups. Name is the cup. Sachin is the content inside the cup. Nescafe is the name of the object. And coffee is the content inside it. So what is a cup? Cup is an object. The cup is a friendly mantra and object is a technical mantra, is what you can think of, guys, okay? Then we looked at type. Type tells you the data type. The data type is whether to understand whether something is a teacup or a coffee cup. whether something is a string or an integer. And then we briefly talked about ID. ID is giving the address ID. When we create the objects, when Python creates the object somewhere in the RAM, it is tracking them using an ID. That is something like your address, memory address, or kind of an address is what we'll say for the sake of simplicity, as simple as that, guys. Okay. Another function. Then we briefly talked about the concatenation. Scroll down, printing the strings. There is again sentence. We looked at a few methods, functions, replace. There is one thing which is special about string, which from a slightly programming or a computer science standpoint, I will ask you to manually remember, guys. Remember, when you change a string is not getting changed or modified. Behind the scenes, Python, .NET, Java, they create new string objects behind the scenes whenever you try to modify. That is referred as immutability. You cannot change a string or you cannot change a coffee cup. If you try to change a coffee cup, behind the scenes, Python is creating a new coffee cup, but not modifying or changing. Slightly from a computer science or a programming standpoint, that is something to be kept in mind. Okay, replace is replacing, lower is lowercasing, upper is uppercasing. Hopefully, if you're finding something difficult, feel free to stop me, guys. And okay, so let me not overload you. If you recall, what do you think is a tray, guys? What did we define is a tray? Can you type in, if you're able to recall, can you type in your answer? It's a list object, good. And there is something special about this list object, Rahul. By any chance, do you remember what is special about the list object? Let's see if I can give you a hint. So take a look at this. Okay, it is a tray in which you can have teacups and coffee cups. In the coming up days, we'll be discussing about another data structure. These are all called data structures from a computer science standpoint. And what are they? What is happening? There are a few data structures which will only allow you to either have teacups or coffee cups, which is either the numerical data or textual data. Whereas list is something which will allow you both. It will allow you to have coffee cups, which is textual data, and numerical data. That is something to be kept in mind. Cool. By any chance, do any of you remember what is append doing, guys? What's append doing? The hint is on the screen. It is concatenating. Okay, I see what you mean, Shrishel. So more precisely, it is no, okay, concatenating is okay. More precisely, it is adding at the end. When you say add brew, it puts brew at the end. When you then say append sunrise, it is appending the sunrise at the end. Cool. Okay. So that is append. What do you think is extend doing, guys? Shrishel, Rahul, what do you think extend is doing? It is combining more precisely, Kajal, what it is doing is it is taking the individual cups, 6, it is adding at the end. Then take the next cup in the tray. In the small tray, it is taking individual cups and adding them into the large tray or the big tray. Catching it, Kajal? Good, okay. Range is a range object. I will not go much into it. So that's where we were, guys. So let's continue our journey. And so I come back here. So take a look at this, guys. Today, I was just giving a thought, a friendly thought, slightly on a friendlier note. Let's, who was a bad boy? Shrishel said he's not the bad boy. He was not looking for a rich girl. Okay. So let's see, here's a girl, look, she does yoga, she does exercises, she does meditation, she's into sports. She's not rich, she's not fair, she's not tall. Okay. So if you do yoga, exercises, meditation, and sports, what do you think will happen, guys? Any thoughts? There is something which will happen if you do all these things. Let's see if you're able to take a guess there. A little bit philosophy here, but bear with me. Cool. Let me run this one. Control Enter, Shift Enter to be more precise. Control Enter will only execute the cell. It will not create a new cell. So let's say, according to my understanding, if you do
storage OpenStack storage ready.
okay, what will happen? Your ego will become less. Cool. If your ego is less, cool, you have a good heart, little bit of philosophy. And what should we do? You better get that boy or girl. If you have a good heart, your marriage, you marry, you better marry them, whether it's a boy or a girl. Okay, guys, that'll make a good family. Okay, so just a slightly friendlier touch of the Boolean operators, guys. Sorry about the philosophy, but I really like that Boolean operator thing, and that's where the Python really helps us and things like that and so on, guys. Okay, so but I won't bore you. I'll leave it to your family, whom you want to marry. I'll leave it to your heart and things like that, guys. Okay, all right. Back to the tray. Long tray and a short tray. We'll dig a little bit deep into the trays today. And that's a list object. The technical mantra is the list. The friendly mantra is a tray of different cups, tea cups and coffee cups. We have two trays. We're appending tray 2. Now notice this, guys. What we're doing is we are doing an append of tray 2. Cool. So if we come here, this here, this here. And so start with the big tray. And here's a small tray. When we do append, what is happening is, take this, it is taking the tray, and what it is precisely doing is, it is increasing the size of it, say increasing the size of it. It's now putting the tray as it is. If you recall, what extend does, say come back here, imagine this is an individual cup. Extend is going to the tray and picking up individual cups and putting, whereas append is putting the entire tray. There's a subtle difference which is happening here, is what it is, guys. Everybody catching? Quick yes, please. Cool, as simple as that. And let's see what else we have now. Now repeating, so I'm just showing you. So it's the same two trays, the long tray, short tray, and extend it, you will see the individual cups being put here. That is individual cups. Cool. And let's see, now a tray of teacups, a tray of coffee cups, extend them, notice the same thing. That should become a tray of teacups and coffee cups. Nescafe, Brew and Sunrise are being added individually. The tray is not being put as it is, that is extend. And do an append, again, repeating the same thing. It's putting the entire tray. Coolness. Okay. So let's come back here and back to Python. A little bit down here. Variables, data types, strings, we talked, operators, we briefly talked, types of numbers, we briefly talked. Let's get into strings. Okay, strings also we talked, lists. Okay, nested lists, we talked about them. Sequence, list, sequence. I think this is where we were, guys. Okay, so we'll go into another data structure and another package, a very popular package and things like that in the world of Python, Numpy package, guys. Okay, let's try to understand what that is. And let me move my chat window here. Back to this one. Okay. So what is NumPy? NumPy is an extension. What is an extension, guys? It is a package. It is an additional, something Python does not have. NumPy has it. So what did they do? They introduced it into your Python. Okay, so Python is our engine. It is the engine of the car, if you recall. But maybe there is a component in the engine. Maybe it is a carburetor. It doesn't, the engine doesn't come with a carburetor. So you buy a carburetor, you get the carburetor outside. What is that? That is NumPy. What is that? That's an extension. A carburetor is acting like an extension. In a Python word, the technical mantra, More precisely, Numpy is a package, is what it is. It has something that Python doesn't have, and that is what we'll try to understand. It had support for large and multi-dimensional arrays. We have multi-dimensional lists and multi-dimensional. We're yet to talk about that. Python has multi-dimensional lists, but it doesn't have multi-dimensional arrays and matrices. And we'll try to get a quick look at what those things are, guys. Okay. It is along with a large library of high-level mathematical functions. So in other words, in the world of scientific computing, Numpy, scientific computing, data analytics, the artificials and artificial intelligence, the machine learning and deep learning world, the package is one of the heart. It is like one of the eyes of all these areas, guys. Numpy and Pandas are the most important packages in a Python world. Is what it is. They have a lot of mathematical and scientific computing functions. More precisely, Numpy has a lot of mathematical functions. In a scientific computing world, they use it very, very heavily, and it is almost a must, guys. Okay. Then Numpy is a fundamental library for scientific computing. There it is. It contains n-dimensional array. We'll try to understand what is an n-dimensional array. The slicing and the dicing. One more time. The similar concepts that we looked at yesterday, we will revisit them and also try to understand how to apply and how they work with arrays. All the concepts that we discussed yesterday will be also applicable here. Reshaping, how do you shape? Shape means you are converting a tray into multiple trays and vice versa. That is what this package gives us, and we'll look at the examples. So some of the examples of mathematical functions are linear algebra, Fourier transforms, random number capabilities, and things like that. So these are the two things which are used in algorithmic trading strategies and things like that. We can use them. That's what these sophisticated scientists do in a financial analytics world and things like that. They try to design various kinds of algorithmic strategies, and they try to make a prediction of a stock price and things like that. That's where all the money is being put into, guys. Okay, by a lot of companies who are into the financial world. Okay. So move to the next one. Numpy's main object is an ND array, or more precisely an array. An array is a homogeneous array. Is homogeneous, multi-dimensional also. In other words, more precisely, an array is a tray in which you can have either teacups or coffee cups. You can have either numeric data or textual data. A list is a tray where you can have numerical data and textual data, but in an array, it won't allow you. You can have either numerical data or textual data. And we can also have a multi-dimensional array. An array is a tray. So here is a tray. Is a tray, numerical data. But notice this one, visualize this one as, this whole thing is one big tray. And there are two trays inside it. So this is a tray of two trays. What is that? That's a two-dimensional tray. What is that? That is multi-dimensional. Tray of trays are referred as multi-dimensional. They're also referred as matrices. Back to school and things like that. We learned the concepts of matrices, I think, in linear algebra and things like that, guys. Okay. So it looks like a table. This is a table of elements, all of them of the same type. In other words, you either have numerical data or textual data. That's why it's called homogeneous. It is indexed by a tuple, similar concepts as lists that we've seen yesterday. We index it, we slice it, we dice it. Then there are a few things called dimensions and rank, which we'll try to understand. So take a look at this. Here is a single tray. We say it's a rank of 1. At a slightly friendly level, we are calling it as a tray. But take a look at this one, a green tray with 2 blue trays. This is rank is 2. It is tray of trays, a tray of 2 trays, a tray of trays. So what is that? That is rank. If it is rank is 3, means a tray of trays. That is 3-dimensional is what it is. And say come here. If you come here, notice this is like 1 tray, 3 cups, right? 1 tray, 3 cups. 3 cups are 3 becoming columns. This is again, notice each blue tray has 3 cups. So it is a tray of trays, rank is 2 with 2 rows here. 2 rows is 2 internal, 2 blue trays. Inside these each blue tray, there are 3 cups. So we call that as columns. Okay, and that's a slightly deep one. That's a slightly tough one. I'll try to help you understand that. But everybody doing okay so far? Quick yes, please. I don't expect you to be perfect, but if you're okay with the slide, cool. Okay, so what is this, guys? This is a tray. of teacups. Here we have indexes going from 1 to 10. As humans, we will read from 1 to 10, but Python reads it from 0 to 9. It's a zero-based index. Programming languages mostly are zero-based index, Python, Java, .NET, except R is one-based index. And now this is a tray of 7 coffee cups. Okay, and now what we have, this is a single cup. A single cup, a single object is what it is. Now what do we do? Here comes what is called vector arithmetics. Okay, let's try to understand what that means. Start here. So visualize a tray. Here's a tray. And here's a cup 1, cup 2, cup 3, and so on. Then visualize another tray. And what we have, cup 1, cup 2, cup 3. Now what is this? We are adding 2 trays. What happens is, visualize something like this is happening. When you add 2 trays, this cup is getting added to this cup because they're the first cup, second cup is getting added to the second cup, third cup is getting added to the third cup. So what is happening is we're getting a new tray. A new tray is getting created. So this will become 115. This will become 36. Oops, one more time, 36. And this is 111 plus 56, whatever that number is, that one. So in other words, more precisely, what is happening is there is an element by element wise operation. What operation? Additional operation is happening. This is, what is this? This is called vector arithmetics. If you go back to school, if you recall the matrices and things like that, in one of the properties of the matrices, one of the characteristics of the properties of the matrices is an element by element wise operation is being performed. Okay, what is that? That is called vectorized arithmetics. Vectorized operations or vectorized arithmetics. Now, what is special here? Instead of plus, you can do multiply, you can do subtraction, division, and things like that. And what is that? Again, they are referred as vectorized operations. The mantra of vectorized operations is element by element wise operation. Everybody catching the point, guys? Quick yes, please. And we'll do some of these exercises in a bit, guys. We'll try to look at some more examples. So what is the difference between, what is this? We'll see that more. If the size is different, we will see it. Let me save that for a few minutes. And back to NumPy. What is NumPy, guys? It is a mathematical library. A library, package, module sometimes are used interchangeably. They are nothing but a group of functions. It gives arrays. Python does not have arrays. So Python is less. So NumPy gives you arrays. What is an array? Array is a tray in which you can have teacups or coffee cups. It will not allow both teacups and coffee cups. It is homogeneous. Lists are heterogeneous. In the world of scientific computing, NumPy comes to their rescue. It is very fast, very quick, and things like that. It has its own advantages. So a lot of low-level operations in advanced mathematical operations and things like that, they use NumPy package. Okay, a lot of sophisticated functions are there. The complex machine learning, deep learning algorithms, they use NumPys. And what are they? They're there as functions or methods and classes and things like that. Again, if time permits, we'll touch them, guys. So it provides a lot of sophisticated functions. C++ and Fortran. It was originally written in C++ and Fortran. The mathematical operations or the functions which are available are related to the linear algebra, Fourier transform, random numbers, n-dimensional arrays, which is what we will look at, guys. Okay. So what is homogeneous multidimensional array? So imagine a tray in which you have all teacups. Okay. So homogeneous multidimensional arrays. Let's see. Come back here. Put this here. And so let's say here is a tray. Here is another tray. No, let me undo this. So here is a tray. For the sake of simplicity, we'll say here is a teacup. Give it a green tea, another green tea. What is this? This is homogeneous because they are both the same. And what is multidimensional? Multidimensional means you take another tray. Choose this one. Take another tray. And what do? Then again, it needs to be homogeneous. You add 2 more cups. For the sake of simplicity, we'll just say 2 cups here. And then what do? Put all these things in another big tray. This is a tray of trays. What is this? This is multidimensional. Because they are homogeneous, they are referred as an array. If they are heterogeneous, then that becomes a list, as simple as that. Okay, what is multidimensional? Multidimensional is tray of trays. A tray of trays is double dimensional. Multidimensional, it is also called a matrix. Okay, so they are faster than lists. The advantage of arrays is the arrays are faster than lists because of their homogeneous at a slightly computer science standpoint, compiler standpoint, they become speed. The speed comes to your rescue. In other words, they're much more faster because of their homogeneity. We can again form nested loops, list comprehensions, and things like that. We'll also get a touch of them. And we think in terms of array that is referred as array-oriented program. Why is that important? If you recall, yesterday we were doing some operations which are just a single word or a single line. The single word or the single line in Python would be 5 to 10 lines of code in the world of Java and .NET. What is that? That is referred as an array-oriented program. That is what we'll also try to review this again, guys. Okay. So here is some examples. Data. Data equals to np.array. What is this? Data. This is a tray of 3 cups. We're just representing them horizontally. You say dot max. It will give you the maximum value. If you say np.array, it gives you a tray of 3 cups. Then we have np.zeros. So let me come back here. Before I go there, let me show you this one and then we'll look at that, guys. So here is a list. Sorry about that. Okay. So here is list, guys. List is a tray. Notice a square bracket. Whereas now notice what we'll do. We'll say list plus 2. So come back here and notice it will give you an error. What is happening is when you say list plus 2, we're trying to add a cup to a tray. But what is the problem? The problem is this is a list object. When you say list plus 2, just visualize you're trying to add a cup to the tray. And what's happening is a list is not allowing you to add it. In other words, we cannot perform arithmetical operations with a plus, an addition operation with a list object. Okay. Now, why is that important? Let's try to understand. Come here, take a look at this. Array ID, array 1D. Just another, we're going to call that as array 1D. We'll try to run it. Notice it gives you an error. What is it complaining? We have seen a few functions. Array is a function, but what is this numpy? Numpy is a package. What is a package? A package is a group of functions. Think of a carpenter. A carpenter has a toolbox. The toolbox is like a package. What is inside the toolbox? A group of tools. What are the tools? The tools are nothing but different kinds of functions. Array is a function. So what is happening is you need to have the toolbox to access the screwdriver or the hammer in the toolbox. If you don't have the screwdriver, if you don't have the toolbox, you will not be able to access, you will not have the screwdriver or the hammer. What does that mean? Well, take a look at this. We'll say import numpy. When we say import numpy, and now, okay, we can ignore these warnings, guys. I'll show you how to not show them. Now, try to say numpy.array, notice no problem. You say 1D. Now notice what it does is it looks like a list object. And what does it have? It has an array in front of it. So it's an array. So this is like a tray which is telling it is homogeneous, which means it can have either teacups or coffee cups. Because one of them is tea, everything is going to become a tea. It is nothing but an array. It is like a tray which will have similar kinds of cups. A list is a tray which has a different kinds of cups, as simple as that, guys. Okay. So what is numpy? Numpy is a package. What should you do? You should import it. What is importing? Importing is like we are a carpenter. And what do? We are opening the toolbox. We do have the toolbox, but we have to open the toolbox to access the screwdriver or the hammer. What is screwdriver and hammer? Well, that toolbox has a lot of tools, and the screwdriver is one of the functions. The functions are like the tools in the toolbox, is what you can think of. Everybody with me so far? Quick yes, please. Okay, so what we have done is we have taken a list, we have converted it to an array, or in other words, we can say we created an array object from a list object, is what we say from a programming standpoint, guys. Okay, let's dig a little bit deep. array. Now take a look at this. Array 1D plus 2. Notice what happens now, no problem. In other words, let's say, come here, put this here. Okay, so here is the original tray. And what are we trying to do? We're trying to add a cup. And how are we doing? We are performing an arithmetic operation. You say, add this cup to this tray. And what is happening? Come here. We're getting a new tray. And now notice 0 plus 2 becomes a 2. 1 plus 2 becomes a 3. And 2 plus 2 becomes a 4. 3 plus 2 becomes a 5. 4 plus 2 becomes a 6. In other words, more precisely, when the size is different, it is still performing what is called an element by element wise operation. We'll look at a few more examples, but I guess somebody was asking what will happen if the size is different. It is still performing, still trying to add perform an element by element wise operation is what is going on, guys. Okay. And what is this? This is called vectorized operations. A list will not support vectorized operation, whereas an array will support vectorized operation. You can add a cup to a tray, or you can add a tray to a cup. What's happening? Element by element wise operation, that is referred as vectorized operation. Everybody with me, guys. Quick yes, please. Cool. Okay. Let's see now, one more time, we're going to repeat this process. Now notice, guys, np.array, a slight and a subtle change going more deep into programming. You say just np.array, it will give you an error. What is NP? NP, we did open a toolbox called Numpy, but we did not open a toolbox called NP. What is it? NP is generally a friendly name of Numpy. Import Numpy as NP. And now what you do, you say, so sometimes if your package names are large, what can you do? You can give them a friendly name. Array 1D, there it is a tray. So Numpy is the package is a toolbox, NP is nothing but the friendly name, just like a abbreviated name or a shortcut. You can give whatever you'd like. So imagine you have someone like Priyusha is the name, is your name. What you do? You can give Priyusha. And now what do? You are using Priyusha.array, and Priyusha is a friendly name for the Numpy package. But in a professional world, don't give your names. It is just to make you understand the concept. The developers or the programmers don't give that kind of names, guys. It is not. The architects generally will have certain standards. They will not allow them to give that kind of names, guys. As simple as that. Everybody catching it, guys? Quick yes, please. Good. So back to the type, if you recall, let's say type, say what is list? It says it's a list object, class list. So type is giving you the data type. And what is a list? A list is a tray of different cups. Ask what is a tray? What is an array? Array is it says a numpy.nd array. It's actually a one-dimensional array. We'll see two-dimensional arrays in a bit, but it is more precisely an array. Array is a tray of similar cups or homogeneous. Okay, so type gives you data type. And again, one more time, just for the sake of discipline, lists do not support vectorized operation. Only arrays support vectorized operation. Let's see how now take a look at this. Instead of a plus, you can do a multiplication. Notice every cup in the tray is getting multiplied. Okay, you can also do other operations, division. If you divide everything by 2, those are the numbers. If you subtract 2 from the original tray, these are the numbers we are getting, the negatives and the positives. All these are referred as vectorized operations in a machine learning world and things like that. These are the concepts which are generally used. And this is called array-oriented thinking. You're focusing on the array is what it is. That is what is called array-oriented programming. Everybody with me, guys? Quick yes, please. Most of the Python developers, data scientists, machine learning engineers, this array-oriented thinking is common to them. And since you guys are into the financial world, if you're looking at stock like data, you want different slicing and dicing of the data, this array-oriented thinking comes to your rescue. It will help you a lot for the people who are in these domains, guys. Everybody okay? Quick yes, please. Okay. All right. Okay, let's see what else we have. Now take a look at this, guys. Import matplotlib. So matplotlib is a visualization package. I'm going to run this one. So if you come here, import matplotlib. Matplotlib is a visualization package. PyPlot is a module. A package is a group of functions and a module. And a module is a group of functions. As PLT is a friendly name. This is a friendly name. Matplotlib is a package. PyPlot is a module. And what is import? Import is a way. So think of NumPy as one toolbox that the carpenter is carrying, in which he has a hammer and a screwdriver. But think of another toolbox the same carpenter has. That is, it has a saw and maybe a wrench and maybe a knife. That's a different toolbox. What is this? This is a different toolbox. It is referred as matplotlib. It is used for visualization, guys. Okay. And let's see, come back here. Okay. Okay. So as simple as that. Now let's see, increasing the complexity a little bit, guys. Here's a slightly tough function. We'll go to NumPy. We are going to take a function called linspace 0, 5. Let's see what it does. Now notice, guys, okay? What linspace is? Linear space. What is special about it is, if you look at this, there are about 11 numbers. If you take a difference between each of these things, it is 0.5. There are 11 numbers. The difference between these two numbers is 0.5. And what is linear spacing? It is equal spacing. You can specify how many you'd like. Let's say, notice this one, change this to 12 numbers. I want 12 numbers. If you take these numbers, notice the difference is almost similar. 0 and 0.45, you add a 0.45, another 0.45, that becomes 0.90, add a 0.45. So what are they? They're equidistant from each other. There is equal spacing between the numbers. They're like the x coordinates in an axis. Everybody catching it, guys? So linspace is generating this many numbers which are equally spaced between this minimum and maximum numbers. Cool? Okay, so let's say you just say, hey, just give me 3 numbers. Notice what it'll look like. 0, 2.5, and 5. Their spacing between them is 2.5. Let's put back 11. Now we'll repeat. Now take a look at this, guys. If you recall, x star star is x to the power of. Okay, so these are y. We are taking every coordinate, every x value, we are squaring it. So 0 square 0, 0.5 square 0 becomes 25, and so on. In other words, we have a few x's and few y's. Now what we'll do, we'll set PLT, which is the friendly name of matplotlib package. Plot is a function. It is a knife. And you give x and y, notice it gives us a visualization. And what is it using? We have given x and y. These are acting like x coordinates. These are acting like y coordinates. We used a function. We generated the data. This is called data generation. In the world of data analytics, back to data analytics, things like that. Many times the clients may say, we don't have any data. Can you generate the data? So there are lots of functions which we, in a data analytics world, they use to generate the data. This, okay? This could be the age. This could be the income of the customers or the clients in a real world and things like that. But here we're just using some mathematical values. And what is happening? Plot is plotting. What is plot? Plot is a blue line. By default, it is drawing the blue line. Okay, everybody so far with me? Quick yes, please. Cool. Okay. So guys, let's take a short 5-minute break and we'll regroup and continue. Have a glass of water. Cool, guys. Thank you. Sorry about that, guys. Just give me one moment here. I'm here. Okay, sorry about that, guys. I'm back here. And move to the next one. For the next one, because of client meeting. Okay, okay. Thank you, Sumit. Thank you for the update. And okay, so let's dig a little bit deep into visualization, guys. Here is the next one. By default, if you notice, it draws a blue line. If you give, so what is plot, guys? Plot is a function. Function is taking a few arguments. A function is like a mixie. And a mixie is something which will take. Thank you, Sumit. I got your message, buddy. Appreciate that. A mixie is something which will take input and it will give you an output. The input is nothing but the vegetables and the fruits. These are the vegetables and the fruits. And what we are getting is the visualization. Visualization is output. So every function is like a mixie. How the mixie is taking the input and converting them to the output. How is it is taking the vegetables and fruits and converting it to the juice. We don't need to worry about it. Okay, so that is what you can think of that one. So by default, it gives you blue color. We can also a little bit of decoration stuff. If you say R hyphen hyphen, notice it's a solid line is now turning into a dashed line. You give two hyphens that is turning into a dashed line. Then come here. Now notice, guys, every time you see a visualization being drawn, notice this message. The Python, the Jupyter is giving us this additional message. To stop that message from coming, you can say plt.show. If you add this line at the end, plt.show, notice that message doesn't come. The textual message doesn't come up. It's nothing too important, so you can do that. You can also take a shortcut instead of plt.show. So you come here. You can just say put a semicolon. Generally, in the world of .NET and Java, after every line, after every statement, you need to put a semicolon. In Python, it is not required. But if you just put a semicolon instead of plt.show, notice it will not give you that message. So this is like another shortcut just to be familiar and just to keep in mind. A little bit about visualization. Now come here, take a look at this X label. As the name suggests, it is a label, and notice that is X-axis title. X-axis title here. Cool. So let's say one more time. Let me come here. Put a semicolon. Copy this. I think maybe I need to put this here. The last line has to be. So X label is X-axis label, as simple as that. And you have the Y label. Let me add a semicolon here. Oops, one more time. Okay. So that is the y-axis title, x-axis title. Then we have the title. Title is the, I also put a semicolon here. That will be the main title. String title here. Cool. Okay. Next, come here. plt.plot, x-axis label, y-axis label, plt.show. This is same as the other one. Don't need to do that. So that's a touch of matplotlib visualization. We'll dig a little bit deep into matplotlib visualization in the coming up days, guys. Okay. So these are all the different functions: plot, x label, y label, title, show, and so on. Everybody with me so far? Quick yes, please. Okay. Thank you, guys. Go a little ahead. Import NumPy. So now let's get into a little bit more detail of the NumPy, a slightly important package, guys. Import NumPy. Remember, when you say import, you're a carpenter, you're opening the toolbox. But sometimes the package names are very, very long. So what do? Most of the time you will see Python developers, networking engineers, they are generally using the shortcuts. So here NumPy, two words are being there, taking the abbreviation and putting them and using them as NP. NP is nothing but a friendly name or an alias. Next here is np.zeros file. Notice what it's doing. Zeros is a function. It is creating a tray of 5 cups and putting zeros. The name of the function is zero. It is explicitly telling. Again, in a mathematical and a scientific, or more precisely in a data analytics world, many times when they're working with image processing data, video analytics data, this is unstructured data, they would require to create images which have all the values at a mathematical level, zeros, ones, and things like that. So a few functions such as zeros and ones are used a lot. So there is np.ones, and let me put this back here. There you go. Time to put this here. There you go. Okay. So np.ones, it's creating a tray of 5 cups, and in each cup it is filling up a 1. As simple as that. Okay, guys. And let's say, come here, take a look at this twos. Now take a look at this. np.twos is not there. Zeros and ones, they're at a computer science standpoint. From a computer science standpoint, they are binary numbers. So they have just given us, NumPy people who designed this package and functions have just given us zeros and ones. They have not given us twos. If you really want twos, what we can do is you take np.ones, and you add a 1 to it. Notice you get twos. Okay, then let's say, copy this one. If you want, let's say threes, what you do, you can also, add a 2, that will become 3. You can also multiply, multiply with the 2, that will also become a 2. These are the different ways in which you can add these things, guys. Okay, so there is ones. You can also multiply this with 2. This is how, if you want more of these things, you can create these things, guys. Okay, you want to multiply with 3s, you'll get 3s. Now here comes a slightly more deeper one. np.zeros, notice 2, 2. And let's try to understand what this is, what's happening here. Put this here, and let's say put this here, put this here, put this here. So this is, when you say np.ones, we're getting a tray, multiple cups in the tray. But what is happening here, guys? Visualize tray 1. 2 cups are getting created. 2 cups are getting created. Tray 2. 2 cups are getting created. Fill everything with a 0 because you're using the 0 function. Then what's happening is these 2 trays, you put them in another big tray. So this we say is a tray of 2 trays. What is that? That is a double dimensional array, or this is like a matrix. It's a tray of trays. A tray of trays is multi-dimensional. This is single dimensional. When you just say a tray, it's a single dimension. When you say a tray of trays, it is multi-dimensional, guys. As simple as that. And multi-dimensional array is also referred as a matrix. This is called array-oriented programming or array-oriented thinking. Everybody with me so far? Quick yes, please. Cool. Okay. So next come here zeros, 2, 3. Say come here, 2, 3. So take a look at this. We have 2 trays and 3 cups. So for sake of discipline, let me come back here. So the way it is working is when you say 2, 3, visualize 2 trays. Let's create 3 cups. A tray, 2 trays and 3 cups, and let's put it in a big tray that is 2 by 3. A tray of 2 trays and 3 cups. Cool, guys? Okay, 2 by 3, that's what, and zeros is filling up the zeros, guys. As simple as that. Next, repeat that with, let's say, ones. Come back here. It fills up everything with 1. It's a tray of 2 trays. Okay, you can multiply that with the 2. If you would like everything to be filled up with the 2. As I said, these are the functions which are mostly used in a financial analytic world also, and image processing techniques and things like that, where this kind of functions come to the rescue, guys. Okay, 2 by 3 again fills up 2 trays, 3 cups, and these 2 trays are in a big tray. So it's a tray of 2 trays and 3 cups is what you can think. Notice everything is numerical data or teacups. They are homogeneous. That's why they're called arrays. Cool, guys. So if we come back here, notice that is what is happening. When we say np.ones, notice all of them are getting filled up with ones. np.zeros is filling up with zeros. np.random.random is filling up random numbers. So random is a function. You give 3, it's filling up 3 random numbers in that array or in the tray. How to give custom numbers via list object? You can convert this to a list object, Srishel. Okay, so take this array. Let's say, we'll start with this one. We call this as, let's say, A1 equals to, let's say, A1. And now, let's say for the sake of simplicity, list of A1. So that is now a list object. It looks like it's a list object in which it has 2 trays. Or more precisely, a much more simple example is, let's say, use this one so that it doesn't confuse you. List of A1. So this is a list object, not an array. An array will say an array like that. This is a list object, it won't say an array. And if we want, we can modify this to a coffee cup. You can add an Nescafe, brew, and sunrise. I'm asking instead of ones and zeros how to give custom numbers. Okay. Custom numbers, one way is you can, if you have the custom numbers, you can fill them up. And we'll see that. And if you want to put some random numbers, you can use the random function. Okay, buddy? But let's say you have some stock data and things like that, you would like to fill up these arrays, then there are ways. We're slowly going there. Catching it, buddy. Very good. Okay. So let's say, now take a look at this np.array 1, 2. So this is like 1 tray, 2 cups, even though it is in a vertical. Here they're showing it as vertical. I showed you as a horizontal tray, but they are showing you this is like 1 column is what they are showing you. Again, 1 column, np.ones of 2, a tray of 2 cups is what we read this as. We're just visualizing a tray in a vertical manner rather than a horizontal manner here. And data plus ones. So what is happening is, notice vectorized operation is coming to your rescue. The first element is getting added to the first element. The second element is getting added to the second element. That is called vectorized operation. So data and ones are 2 arrays. When you add the 2 arrays, you're getting 1. When you add 2 trays, you're getting a single tray with an element by element wise operation. We can do multiplication, subtraction, division, whatever we would like. These are all vectorized operations, slightly important in a mathematical or an analytical world, guys. Okay. Now notice here something different here, guys. We have a tray of 2 cups here. We're multiplying with a single cup. Put this here, put this here, put this here. So it's a tray of 2 cups. You're multiplying with a single cup. So what is happening is, this is getting multiplied with this one, this is getting multiplied with this one, that is equal to, okay, yeah, simple as that. That's what is being shown here. It's as if it is NumPy is creating another tray which is of equal size. It's filling up. This gets multiplied, you get 1.6. This gets multiplied, you get 3.2. In other words, This is getting multiplied with this cup. This is also getting multiplied with this cup, and we are getting that result. Catching the point, guys? Everybody with me? Quick yes, please. Okay. Okay, so now here comes the slicing and dicing. Before we go there, let me come back here. Now take a look at this, guys. Here is matrix. Matrix is another function. It is nothing but a double dimensional array, a tray of trays. So I come here, put this, run this here, np dot matrix. Now this is a tray of a single tray. A tray of a single tray of 3 cups. Here is another tray of 3 cups. Now notice what we are going to do. Notice we will use something called head stack, horizontal append. Okay, so what is happening is this here, put this here. Okay, so visualize we have a tray in which we have another tray and in which we'll put some cups. So here is the first cup for sake of simplicity. Here is the third cup. We'll repeat the same thing. There is 1 cup here, there's a third cup here. Put this inside the tray and visualize that inside another tray. Now what is happening is horizontal stack is as if we are taking this tray here and you put this here. So 1, 2, 3 are coming up to here. Okay, then take the 4, 5, 6, put it horizontally. Okay, then what is happening is just visualize this is becoming a new tray. Okay, so let's join these two. So that is becoming a tray of 6 cups. It's putting them horizontally. It is picking up the 2 blue trays. Why is it picking up the blue trays and not the green cups? Well, that is the first item. In each pink tray, the blue tray is the first item. The blue tray, the blue tray. The pink one is mapping to the outer bracket. The blue one is mapping to the inner bracket, to be more precise. The blue one is going from here to here. From here to here. So for the pink one, when you say, give me the item, it is not the green cup, the item is the tray. So that's why it's getting the cup, the tray here and putting it here. And what is it doing? It is horizontally putting it. That is referred as a horizontal stack. That's what head stack. And again, this is a little bit of array-oriented programming, guys. Okay, but let's say take a look at this. To understand that, we'll do what is called a V stack, and we get 1, 2, 3, and 4, 5, 6. In other words, what is V stack doing is it's taking the blue, put 1, 2, 3 here, then put the second tray here. So you're now putting vertically, not horizontally. Then let us say use this one. We already used that one. Let's say use this one. Put them there. So 1, 2, 3 is on the top. 4, 5, 6 is below. And that is what is being shown here. This is actually 1, 2, 3 on the top. 4, 5, 6. It's while printing, it is printing like that. It is not. So it is not a. So in horizontal stack, they are all becoming one tray. All the cups are getting into one tray. So here the trays are, since they're sitting on the top and the bottom, the trays are separate. Everybody catching the point, guys? Maybe this is something I will ask you to manually remember. Have an idea. Have a clue of this. Quick yes, please. Cool. Okay. So let's say that is vertical append. Let's say, take a look at this. Now take a look at this, guys. We'll go one step deep and try to look at a slightly more complex example. This is a 2-dimensional tray. This is a 2-dimensional tray. The first one. And here is another 2-dimensional tray. 1, 2, 3, 4, and here is 5, 6, 7, 8. Now what we'll do is we'll repeat the head stack or the horizontal append. Run it. And if we come here, say, come here, back here. Let's try to visualize this. Choose this one. So visualize, let's say, first tray, second tray, 2 cups, and here is put the 2 trays, 1, 2, 3, 4. Okay, then repeat the same thing, which is a big tray inside which 2 pink trays, and put 2 blue cups. That will be 5 and a 6, 7 and an 8. Now what are we doing? We're doing head stack. So what is happening is, okay, so visualize horizontal stack is, it is taking 1, 2, take the first item, or I'll leave it here. So the first item is being taken, is put here. Take the second item is not, it's not going here. From here, it is going to the first item in the next tray. So the first item in this tray is going to the first item in this tray. This 5, 6 is being taken and is being put here. That's becoming 1 tray. So 1, 2 are coming from here, 5, 6 are coming from here. That becomes 1, 2, 5, 6. Repeat the same process. 3, 4 are coming from here, 7, 8 are coming from here. That becomes 3, 4, 7, 8. Okay, so in other words, let's say we'll get rid of this one, get rid of this one, get rid of this one. This is 1, 2, 5, 6 for sake of simplicity. This is 3, 4, 7, 8 have now found. Then what you do, we will put them in a new tray. That's a tray of 2 trays with 4 cups in each. That is what is happening. So in other words, more precisely, what is slightly complex here that I will force you to remember slightly from a programming or a computer science standpoint, guys. For the green tray, when you say the item, the first item, it is the pink tray, not the blue cup. Your tray is becoming the item. In other words, think of this one, the green tray as the parent. The child for that is not the blue cups, but it is the pink trays are the child. The blue cups are the grandchild of the green. So it is going to each child. Take this child, put him here. Take the first child in the second family, put them here. Similarly, repeat. Take the second child in the first family, put that here. And take the second child in the second family, put them here. A vectorized way of picking up the items. And what's happening? Put them into a new family. That's becoming a new family. Catching the point, guys? Everybody with me? That's a slightly tough one, but if you get an idea, that should be good, guys. Okay, but we'll see. Does both array need to have the no? You can have different operations. We'll look at that in a moment. Let me just complete this. So here is again repeat the vertical stack, and let's say come here. So there is vertical stack. So what is happening in the vertical stack is, let's put these things back here. And okay, so in vertical stack, guys, it is taking the first child, put it here, 1, 2. Then it takes the second child, puts it vertically, and then take this one, and then take this one, and put all these things in one final. So if you notice, 1, 2. When you say vertically, it is taking up each item and putting them in a vertical manner. It is not doing a vectorized way of picking up. It is just taking the first item, then the second item, then the first item, then the second item, putting them in a horizontal, in a vertical fashion is something. Again, that is something, how it is working is something to be kept in mind, guys. Okay, maybe there's another way of explaining it and simplifying it further, but maybe we'll revisit that and see if we can simplify it more. Catching it, guys? Everybody with me? Quick yes, please. Vertical is it is taking the children and putting them vertically. Horizontal is it is taking the children and putting them horizontally is one way. The pink trays are the children of the green trays. So I come here. So there are the pink trays. For the green tray, the children are the pink trays. For the pink trays, the children are the blue trays is what it is. Catching it, guys? Quick yes, please. Cool. Okay. Yeah, that's a slightly tough one. I'll see if I can simplify it further. And let's see, come here. So now take a look at this, guys. Matrix. Now what do we have? Matrix is a double-dimensional array, multi-dimensional. So you're giving a tray here, which is a tray of 4 cups, but you say matrix. Notice what happens. Notice it's giving you a tray of a single tray of 4 cups. Repeat that with another tray with only 3 cups. So this is where you have different sizes. Now what you do, repeat the head stack. Notice what happens. 1, 2, 3, 4, which means, let's say, back here. Cool. So here is a tray, 4 cups inside the tray. Let's say here's a blue tray with a pink tray. Here also a blue tray with a pink tray is the child. Horizontal append, what's happening is, even though they are different size, 1, 2, 3, 4, it's picking up the child, and putting them horizontally. But, okay, and puts them horizontally, and let's say that is puts them inside another tray. But, come here, and try to perform this. Notice it gives you an error. Okay, it gives you the Python error messages are not very user-friendly, may not be user-friendly. It is not a guarantee guess. It might be slightly confusing. All the input array dimensions for the concatenation along dimension 1. In other words, more precisely, the first one has 4 cups. The second one has 3 cups. When it is trying to put this vertically below, it is observing that their size is different and VStack is not being allowed. There is again a computer science algorithm, like their own logic and things like that behind the scenes from an array standpoint. We don't need to go into that details, but just have an idea about that. For the vertical stack, if the size is different, then it is not performing the operation. Everybody with me, guys? Quick yes, please. Okay, now take a look at this. Array 3, put back 4. If you have 4, there should not be any problem in the VStack. So come here. No problem. It puts it back, works fine, and things like that. So let's say back here, so there is data. So here's a little bit of slicing and dicing, slightly advanced topics. But let me just give you a quick touch of it. Data of 0, a tray of 0 means you're saying, hey, give me the first cup. Say, come here. This here, put this here. Okay, for sake of simplicity, tray. 3 cups. So this is saying, give me the first cup. And this is saying, give me the second cup. As simple as that. That is what is the second cup. So 0:2. If you recall, the mantra is inclusive versus exclusive. The left-hand side index is inclusive. The right-hand side index is exclusive. 0:2 means you're asking it, hey, tray, give me the cups from 1 to 3. In a human language, 0, 1, 2. But the right-hand side index, which is the third cup, is exclusive, so it is giving only the first 2 cups. In other words, the mantra, the left-hand side index is inclusive, right-hand side index is exclusive, is also applicable for arrays. It is also applicable for the rest of the data structures that we'll be getting a touch of, guys, okay? Then come here, data 1. 1 means second. And right-hand side index, they have not given it till the end. So it is starting from here, and going and picking up, and that is what that is becoming. Again, the mantra is inclusive versus exclusive, left-hand index versus right-hand index. Catching it, guys? Quick yes, please. Okay. Okay, so one more time, one of the advantages of the arrays is you can perform operations like that. You can take a tray and say, hey, give me the maximum, give me the minimum, give me the sum, and it's performing all these operations. What is one function? What looks like one function of method here? In a Java world, we may write a for loop, a nested for loop, or just maybe a single for loop would be fine, but that would be 5 to 6 lines of code to get to that stage in a Java world, guys, okay? And there is here, we have straightforward function. So there it is, 1, 2, 3, 4. So that's like a tray of 2 trays with 2 cups. Cool. Let me just move this here. Put this here. One more time, just for sake of discipline, put this here, put this here. A tray, oops. Big tray, 2 trays inside, cup 1, cup 2, cup 3, cup 4. Just my chat window. Okay. Then let's see what else we have now. np.ones, we have seen this. You can fill up random numbers. Once 3 trays, 2 cups. The left hand side, this is 3 trays, 2 cups. This is 3 trays, 2 cups, but filled up with zeros. This is filled up with random numbers. Cool. Then data plus ones, and what is happening is, looks like an element by element wise operation is happening. 1 plus 1 becomes 2, 2 plus 1 becomes 3, 3 plus 1 is 4, 4 plus 1 is 5. Again, a vectorized operation or an element wise operation is being performed. That is what is That's what it is about, guys. Okay, as simple as that. So similarly, now different dimensions here. We're adding only one row, 2 columns here. There are 2 rows and 3 columns here. So what is happening is it is kind of, you can kind of visualize as if what NumPy is doing is, since the dimensions are different, here, it is taking this one and transforming it into equal number of dimensions. It's kind of replicating itself with same dimensions, 2 trays and 3 cups, and filling up whatever the values are here. And that again, 1 plus 1 becomes 2. 2 plus 1 becomes 3. And so on, guys. Okay, please. Okay. And 4 plus 1, that becomes 5, and so on. Just a last check, 6 plus 1 is becoming 7. Okay, guys, so this is a scenario where we have different kinds of dimensions of rows and columns. Quick yes, please. Everybody doing okay? Cool. Okay. So now here is a dot. Dot is nothing but a dot product. Back to school and colleges, I think if you have a dot is a function. And I think that gets, the first element gets multiplied with that one, the second one with this one, the third one with this one. So that's like a mathematical operation which is being provided to us as a function. And if you have to write a dot product function, maybe that will be a bunch of lines of code and things like that. So there are lots of functions and algorithms also, which are available as part of these packages, guys. Okay. So again, a little bit more. What are we doing? We're doing a sum of these things. And also, in other words, we're just explaining dot, how the dot is getting performed. Well, this is what is happening. That's how we're getting those values, guys. Okay. Now let's see, come back here. Okay, one more time. This is referred as slicing and dicing. You have a watermelon, you have a group of family members. What you do? You dice, you slice and dice it. Data of 0, 1 means first row. So this is the first row. And let's say this is the second row. This is the third row. All these things are inside third tray. All these things are inside a big tray. So when you say data of 0, 1, it is going 0 means first tray. First tray is this one. 1 means 2. So that is first tray, second cup is what that is becoming. Then you say 1, 3, that is inclusive, exclusive. 1 means second tray till, colon means go till third. We have only 3. Third means fourth. So what is happening is, it is starting with the second tray. It is going till the third tray. There is no fourth tray. So that's why you see 3, 4, and a 5 and a 6. In other words, again, the inclusive and exclusive mantras are coming to your rescue. Now take a look at this. Instead of a colon, we use a comma here. The left-hand side of it is explaining which are the trays you need. And 0 is explaining which is the column, is what it is. Okay, so let's see. Go to Aniket. So where is he? Aniket, you can unmute yourself, buddy. Sorry, unmute yourself, buddy.
Yeah, I'm audible now. Hello.
Yes, you're audible, buddy.
Yeah. So I was saying, sorry to interrupt in between, but I have a doubt actually. So what we are learning now is analytics perspective, right?
Okay.
Yeah. So like, how is it gonna help in doing the AWS scripting? Means what we actually initially requested was for the scripting of AWS. Like we work for Lambda functions and everything, right? So for that purpose, we were have requested for the scripting in Python.
That's what this is. I'm coming there.
Yeah. So what we are doing right now is for analytics purpose, right?
It is just part of the analytics, Aniket. As simple as that. But yeah, I'm just beginning with the scripting.
Yeah. So like, are we going to cover that, right? Means for the scripting which we will be doing on AWS, like the Lambda functions and everything.
Yeah. We'll be learning Lambda functions and things like that.
Okay, fine.
That's what I have here. Okay. I'm coming there, buddy.
Okay. Sure.
I'm giving a touch of the various aspects of Python here, as simple as that.
Okay, cool.
One moment, please. Okay, sorry about that. So you come back here. Okay, guys. So let's get into a little bit of functions and things like that. And we'll start with, again, a basic function. Like here. So there is print. Print again is, as the name suggests, it's a simple function. Printing Mera Bharat Mahan. But let's say you have a need to print Mera Bharat Mahan multiple times. There it is. What is the problem here, guys? We are going to be typing it, or maybe copying and pasting it multiple times. If it is maybe 10 or 20 times, it might be unproductive, but we have to type a lot, and we have to copy paste it. But if we have to do it 100 times or 1,000 times, that would be too much unproductive, guys. Okay, so what do? That's where we bring in the functions. So take a look at this. The functions are nothing but a group of lines of code which are centralized at one point. We are most of the times using functions in the world of scripting and things like that. And let's see what we have here. So there is greet. And what do? Once we define a function, you call the function. There is printing it, guys. Okay. But ideally, a few things need to be kept in mind when defining a function. The first thing is, if you don't give a colon, Python is complaining. Is one thing to be kept in mind. Second one is indentation. You don't give an indentation, it is complaining. In other words, more precisely, Python is forcing us to give a colon. Python is also forcing us to give a tab, provide a tab, and then run it. No problem. Once you define a function, what you do? You call the function. Okay, guys, that's all. So what is the problem that we are facing? Unproductivity. What is unproductivity? Copying and pasting. We have not yet solved the problem of unproductivity. How do you solve it? But that's where we use the loops. Okay, so imagine if we are just using the function, we can also call it maybe 10, 20 times like that. We are probably typing less. We are probably typing less, but our problem is not solved. So what do? That's where we use a loop. So there is a function, it takes an argument. Remember, function is like a mixie. It's taking an input, and what you do inside is based on your requirements. Okay, so now if we say greet n and say 5, that will print it 5 times. You can change that to 50, 500, 5,000 or 50,000 times. And what is it? That's about only 4 to 5 lines of code, which we are printing in. We do not have to copy paste it multiple times, guys. Okay, so if we go a little bit into the functions, okay, so think of it like this. A function is like a house, and inside this house, when we say what is happening is, you visualize to get into this house, you need to go with a cup. Here we have come with 50 or maybe a 5. Okay, so to go inside this house, this is the input. That is nothing but the argument. This is nothing but the small n. When you say I equals to 0, we can visualize once you go, the first step which is happening inside this function is you create a cup, you're putting a 0. Then comes the while loop, something I will ask you to manually remember. What the while loop is doing is, you are now in the next step comparing the I is the green. The green, is it less than the blue? The comparison 0 is less than 5. Yes, that is true. So what you're doing is you're printing Mera Bharat Maham. You're saying, hey, Mera Bharat Maham. Ideally, you will do whatever the operations that you need to do based on your requirements. Then in the next step, what you're doing is we're incrementing. We're adding a 1 to this one, which means you change this one, you add a 1 to it, and that becomes a 0 plus 1 is 1. And then again, you're checking, hey, is the green cup less than that one? That is a true. So what you do, you repeat the step. Say, Mera Bharat, and then you go back and add 1 to it, so that becomes a 2. You repeat that until this becomes a 5. And that's when the loop fails. And in other words, that's when the condition becomes false. When 5 is less than 5 is becoming false, you can, it will not go inside the scope of the while loop. I'll also explain you what is scope and things like that. So Aniket, if you can come back onto the line, buddy. So the reason I was covering some of the basics and the complete part is because some of them are coming from non-programming background and some of them are coming from things like that. The first 2 weeks I thought I'll focus on, that was what was agreed, and then we'll get into a little bit more into the AWS stuff and things like that. If you guys are already familiar with the while loops, for loops and things like that, you can let me know. I will directly go into slightly more advanced concepts and things like that, buddy. Feel free to let me know.
No, I think we can cover the basics part here.
Okay. Yeah, that was what was told to me because I guess for a few of them, majority of them are all coming from non-programming background. So a touch of Python would be helpful for them. So that's the reason we're covering various things and is what the plan is, buddy. But feel free to let me know whenever you think if something needs to be skipped and things like that. Okay. Okay. So that is slightly a heavyweight one to start with functions right away. But let's take a look at a few more things, guys. Now take a look at this. Here is something that's, when you say greet and, notice this one. I'm going to put my cursor here, and I'm going to do what is called a shift and a tab. I will be doing it multiple times in the coming up days. Shift and tab is how we get help about this function. Now notice there is something called a doc string here. Doc string says it is no doc string. What the doc string stands for is a documentation. It's a documentation string. Generally in a Python word, where you will see the developers whenever they write a function, they are expected to give a brief description, a single line, maybe 1 line or a 2-line descriptions of what that function is doing. So it is the same function. Now come here, put this here. So this is the line I have added in a triple quotes. Generally, for sake of discipline, we put that in a triple quotes right after the definition. Def is the definition. This is also called the declaration. You just add a 1-line statement, what that function does. Now let's run it. Now let's say greet and let's say 5 for the sake of simplicity. You ran that, put your cursor here, say shift and a tab. Notice the doc string says prints Mera Bharat Mahan and tags. Why is that important? Many times you may have written some complex functions and things like that. Every other person, imagine Nitish has written something today. Humera is looking at it tomorrow. Because Nitish has done all the complex work today, Humera and others need not try to look into the complexities of the function. So imagine Nitish gives a simple description saying, hey guys, this is what this function is doing. If you have a need like this, just go ahead and use this and call this function. Is a brief description that is referred as a doc string. A standard practice, many times you will see a lot of architects and senior people will be forcing you to provide a quick one-line description. It is most of the times when the seniors are looking at your functions and things like that, they would like to just look at the docstring, get a feel of what your function is doing, is what it is about, guys. Okay, everybody with me? Quick yes, please. So here, one of the things is shift and a tab. I do a shift and a tab for all the other functions also. It will give you. So notice this one, guys. We'll say print. For the print function, which is a built-in, we'll do a shift and a tab. Notice it's giving you a description. You can expand that. It says it prints a value to a string, to a std out, and things like that. A little bit of computer science way of explaining and things like that, guys. So anytime when we use the built-in functions, shift and a tab is your way of getting details about that function, guys. Okay. So print Mera Bharat Mahan while I is less than n. Okay. Now there are a few more, couple of more things which. Okay. Greet and def greet. Okay. So here is another quick and quick thing you may want to keep in mind. Yes, when we are defining a function, a few more syntactical things that you need to keep in mind is notice capital D. Notice when it is small d, Jupyter is turning it into green and bold, which means Jupyter is recognizing that means that is a reserved keyword. It is used by Python. Okay, no problem. You try to execute it, no problem, but change that to capital D right away. It gives you an error. So in other words, there is a difference. It is case sensitive is what it refers to in a programming word. Cool. And another thing you may also want to keep in mind is come here. Notice this one. Not only for these two, the tabs or the indentation, guys. Okay. If I do not give this tab or indentation, notice no tab or indentation is not given. Python will not understand. It will force you. So let's say it will force you. Indirectly, it's saying, hey, I'm not understanding what you're doing. Still forcing you. Now, when you come to while, okay, gives you error. Why? Because the while also enforces its scope. What is scope? I'll explain you in a bit. This is in a bit. I'll explain you guys. So notice now it doesn't. So in other words, these two we say are in the scope of while, and the while and these three are in the scope of the function. What is the scope? Just give me a few minutes. We'll try to come to that in a bit. Okay. That's what it is. Now let's try to understand the scope, guys. Take a look at this. Print Hamara Bharat, and then we are defining a function, and then we are printing Hamara Bharat. So if we go to run this one, notice only Hamara Bharat is getting printed and Mera Bharat is not getting printed. Why? Because once we define a function, you make sure you're calling the function, which means come here, say greet. There is Hamara Bharat, there is Mera Bharat and Hamara Bharat. Now, gentlemen, ladies, now let's try to get a feel of what the scope is. So come here. So by default, this is the entire Jupyter notebook. Think of this as a park. And what you have is, let's say, Hamara Bharat. When you say Hamara Bharat, oops, just select another one. When you say Hamara Bharat, it is not inside the function. If you're not inside the function, you're not inside the house. What is greet? Greet is a function. Function is like house. Oops, one more time. Choose this one. So here is a house, and this is a function. So where the Hamara Bharat is outside the function. So that is called global scope. If you're inside the function, what do you have inside the function? You have Mera Bharat. And then you have Hamara Bharat again, which is outside the function. How do you know it is outside the function? That is what the tab or the indentation is about. As long as you have the tab or the indentation, you're inside the function. That is the local scope. Your local scope is you're inside the house. Are you outside the house or are you inside the house? If you're outside the house, you're in the park. If you're in the park, that is called global scope. If you're in the house, that is called the local scope. Is what it is, guys. Hamara Bharat is in the park is global scope. Mera Bharat is inside the house is what is called the local scope. Everybody with me? Quick yes, please. We'll try to simplify it a little bit further. This is more of a syntactical thing that we need to remember manually, guys. Python is indirectly forcing. When you write a function, if you want to put something inside that function, you need to give it in a local scope. How you do that? You give a tab or an indentation. It is more of a syntactical thing. When you drive a car, you need to press the brake, you need to accelerate the accelerator. put your leg on the accelerator, otherwise the car will not move. What is that? That is more of a method and a procedure. That is the syntax of the car. Just like that, the syntax of Python is asking you to tell it which one is local scope versus which one is global scope, guys. Okay, so we'll look at a few more examples to simplify that. So there it is. Hamara Bharat global scope. Greet is where we are calling. When you call it, you're going inside the house. You go inside the house and you perform whatever is the business logic or the logic that you would like to execute there. Cool. Then Nescafe. Print Nescafe. Ram is like a house, Ram's house. Brew is in local scope. The same thing, just with a different things. So let's say if you run this one. So Nescafe and Sunrise are in the global scope. They're in the par. Brew is in the local scope is what it is. The same example, I just used a different words here, just to kind of, just for the sake of discipline so that you get the terms and the words here, guys. Quick yes, please. Everybody with me? Okay, so back to subplot and things like that. Okay, back to a little bit of visualization. One example, PLT is the friendly name of the package. Subplot. Subplot is 1 to 1, and we are going to plot it. So let's see what happens here, guys. Take a look at this. Okay, so 1 is the number of rows, 2 is the number of columns. So it's saying you're requesting, and I need something with 1 row and 2 columns and 1 cell. In the first cell, what is happening is it is putting the X and Y coordinates with the red color line. That is what is happening. Subplot is another function. Plot is a function which is actually drawing the plot. Subplot is you're giving the specifications. How many rows and columns you need is what it is, guys. Okay, so to understand that, now take a look at this. Here is subplot, 1 row, 2 columns. In the first cell, put a red color. Here in the second cell, put a blue color. So that is like 1 row and 2 columns if you are visualizing it, guys, if you're looking at it. Yeah, say this 1 row. And think of this as first column, and think of this as second column. Cool. Everybody with me, guys? Quick yes, please. Okay. Okay. Please take a short 5-minute break, guys. We'll regroup again in 5 minutes. Yes. Back here. Let's see. T-dot figure. Field T-dot figure. Yes, US. Making slight change. Give me one moment here. There you go. Quest set. So cut this one here. 27. This combinations, these are going to be important, right? So 3102. Let this here. 3112. So this one. Tokens and sets. Exceptions. Okay. Take this. Scroll up here. Oops, sorry guys, just interchanging some stuff here. Give me one moment. For loops, length, students, lambda functions, okay. Okay, so we good place. There you go. May resume the share. Okay, hope you're able to see the screen. Starbucks, and let's dig a little bit deep. At plotlib, just looked at the numpy's functions. Okay. Subplot. Okay, back to functions and things like that, guys. So there it is. Santosh House, just another function. We've just looked at the while loop. I think we can skip this one. We don't need that. Vidya House, I think again, it's okay. So take a look at this, guys. A subtle and a small thing that you need to be aware more from a programming standpoint. Here is a function which says it is Santosh House, taking one argument, doing the same thing, printing Hamara Bharat, how many times you want. And let's see how the output looks like. Notice we're just printing here. Print is just an execution. But sometimes when we execute a function in a script or something, we would like to return something. What is it? That's what is return. Oops. That's a return. In other words, it is the same function, and then I have added a return. Return is in the scope of a function. The print and increment are in the scope of while loop, is what it is. So what is happening is, if you look earlier, when we did not do return, all it is doing is executing it. And sometimes you want to return something. You want to return a gift. You go into a function, you go into house, when you're coming out of their house, they're giving you a gift. That is what is a gift. When you return something, what is happening? Notice how it looks like. It says out. Pardon me. So in other words, this is execution part. Based on your requirements, sometimes you may just want to execute, you may just want to print saying that, hey, I executed this, I executed that, and things like that. But sometimes you may want to return some data from that. That could be a simple teacup or coffee cup and things like that. That is what is output. Okay, so return is when you want to return some objects or return some data. That is something which we need to keep in mind, guys. Okay, something I will force you to remember or kind of manually remember is what it is. All right. So now let us see what we have. Red label is 0, and going a little bit deep into the scope and things like that. It is just a teacup. Red label is a teacup. We are putting a 0 inside it, and it is outside the function. If it is outside the function, it is in the global scope. Global scope means it is in the park. By default, your Jupyter notebook is a park. Inside that park, we build some houses and things like that. So here is a function, Ravi house. So this is like house. To get into this house, we need 2 arguments. You need to go with 2 cups, Brook Bond, and Taj. And then he's doing some processing. So let's define the function. And now let's see what is going to happen, guys. Take a look at this. we have a cup called Blue Bond, we have a cup called Taj, we have a cup called Red Label. So what you do, say red underscore label, you don't have any problem. Python does not complain. But say Brook Bond, notice it gives you an error. Okay, what is Brook Bond? Brook Bond is a cup inside Ravi's house. It is not a cup in the park. These are nothing but the objects. Objects are nothing but the cups. And what is special about them? They can be in a global scope or a local scope. We need to have a precise understanding what is local scope versus global scope. That's a slightly tough one. So just bear with me if I give you multiple examples, guys. Okay. Just my computer. Okay, so Brook Bond, you cannot access a cup in somebody's house. Okay, try to access Taj. It'll give you an error. Python is catching it. Lipton. Python is not going to allow you. It says it is not defined. Defined means it is not created. More precisely, we have Brook Bond, Taj, and Lipton, but these are nothing but the cups inside the house. You cannot access the cups or the objects in a local scope. If you're inside a function, you're in local scope or inside a house. Okay, red label is outside the function. In the global scope, you can access, but you cannot access something which is inside. So what do you do? What you do is, let us say, take a look at this. Here is Ravi. Now say, sometimes when I copy paste these things, it gives these special characters. So don't worry. You say, let's say return Brook Bond. Okay, now run it. Let's go into Ravi's house. Ravi underscore house. Let's give 1, 2. Let's run it. And we're getting a 3. So what is happening inside is there is some kind of processing that generally depends on your requirements and so on. Let's say come here, put this here, put this here. Okay, take a look at this, guys. Ravi house. So Brook Bond is 1 and Taj is 2. You go with 1 and a 2. And the first step that you're doing is you are creating a new cup called Lipton. You're putting a 0 inside it. Plus equals to 1 is where you're adding a 1 inside the green cup. So in the next step, you visualize as if you have changed the Lipton to 1. Then you're taking, so we have come with Brook Bond as 1. This is 2. Visualize this as a house just for a visual help. And these are the 2 cups. Sorry, here is the first cup. Here is the second cup. When you call the function, you're triggering the function. It's like you're going inside that one, inside the house. So here is you are creating Lipton was initially the first step, which was put a 0, then you add a 1. You add a 1. Now you're taking the Brook Bond, which had a 1, and what you're doing is you're taking whatever is in Taj, which is the blue. There was a 2 here. So take whatever is in this one, put it into this one, and then you add whatever is in Lipton. So what is happening? That is becoming a 3. Okay, so we're printing a 3, whatever is inside that cup, and then we are returning that one. What are we doing? It is something like return Brook Bond. We're trying to access Brook Bond. So what do? You return it. If you want to access it, is one way to think of it. More precisely, more importantly, Brook Bond, Taj, and Lipton are cups in the house that is there in the local scope. Red label is in the global scope, is something to be kept in mind. Everybody catching it, guys? Quick yes, please. You will come across using those local scope and global scope a lot in the coming, whether you're in scripting world or a completely programming world and things like that, guys. Okay, that's a slightly or more precisely a very important topic. Everybody okay with that? Quick yes, please. We'll look at a few more examples just to help you out and things like that. And let's see what else we have, guys. Okay, so that's just this different names here. Okay, so take a look at this, guys. Haima, Bharat and Mahan and Hamara. Notice, if we run this one, Haima is a function is house, but what is happening? Only Hamara is getting printed. Hamara is not inside the house, it is not in the local scope, it is in the global scope. Bharat and Mahan are in the local scope. So if you want to print Bharat and Mahan, you need to call that function. Calling that function is like you're going into Haima's house. So here is Haima. So there is Bharat and Mahan. Okay, more precisely. So in other words, when you call the function, whatever is inside is getting executed, is what it is, guys. One more time, Hamara is in global scope. It is in the park. Bharat and Mahan are in your house. They're in the local scope. Cool. And now take a look at this, guys. Just for sake of discipline, we're defining the function. This is more of a syntactical thing we need to keep in mind. What's happening inside a function, you cannot have one line not indented and another line indented. Python is catching it. Python is saying, hey, complaining. So what do? Put it back. Okay. Now, let's say undo that one. We'll put that back. We'll execute that. So to fix that, we did this, which is you put that into local scope, no problem. But take a look at this. You put this into local scope, put this into global scope, no problem. Bharat is in local scope, Mahan is in global scope. There's a subtle difference. When you had Bharat in the global scope inside the function, inside the house, you went into the park. From the house, you came into the park. And then you're going into the house, that is not valid. In other words, you cannot access, you cannot go into the global scope when inside your house. If you go out of your house, you're in the park, is one way to visualize that, guys. That might be slightly confusing, but I'll see if I can simplify it. More precisely, why it is working here is Bharat is inside the house. After you said Bharat, Mahan is outside the house. It is in the global scope. Okay, guys. Let's see. Others are doing okay, guys. I'm seeing only response from Rahul. Are you guys doing okay? Are you able to understand it? Okay, just keep me posted, guys. So again, the same example with different names. Bharat Mahan are in local scope. Hamara is in global scope. And Bharat Mahan. Again, now notice this, guys. We're adding a return here. Here is the house of Sanjay with a return. But more from a syntactical standpoint, generally when we use a return, you don't return it in a global scope. We use return inside a function, which means inside a function, you put that and say it doesn't complain. If you put that in global scope, it is generally a problem, something to be, another thing to be kept in mind. You don't return in the park. You return only when you're coming out from a house. Or return is generally applied in a local scope, not in a global scope, is what it is, guys. Okay. Okay. And again, another simple thing to be kept in mind. Why is none of them getting printed, guys? Because you did not go inside his house. You did not call the function. There it is. So when it says out, that means that it is returning. If it is not giving out, and if it's just showing output like that without output, that means it's just printing. Some execution happened there and you're just printing there. Many times for logging and things like that, we will use the print statements and so on, guys. Okay. Okay. So again, the same thing, different name and the same thing. And another useful function, guys. Okay. So take a look at this. Let's see what is 10. We all know it's integer. Say type of 10. It'll say it's integer. But what is happening when you type in 10? We are hard coding it. Okay. What if you want a user to enter something? You want a user to enter something. What do? That's where the input comes to your rescue. Cool. So take a look at this. Give it a moment. And now let's say we enter 20. What is it? It's printing 20. And now, okay, if you look in X, what is it? It's at 20. So what is input doing? Input is asking a user to enter. Many times we may have come across scenarios, we're writing some scripts where we want the users to enter something, some input. It could be a number, it could be some other option and things like that. That's where we use input. Now here is something slightly different, guys. Take a look at this. There is a subtle difference between this 20 and above 20. What is the difference, guys? Can anyone of you spot it? It's a string. Okay, a bit of programming context there. So what is happening is, if you say type of X, notice it says it's a string. In other words, something we need to keep in mind is when you use the word input and when you say enter something, what Python does is anything that you enter, it will take it as a string, not as a numeric value. Even though we're entering a numeric value, it is saving it as a string internally. Okay, so let's say enter a number. So now notice this one. If you run it, let's say enter a number, enter psi. Now what is there? Well, X will now have psi. Why? Input is converting everything to a string or a textual data or to a coffee cup. Okay, so ideally, one more time, here is X. Let's run it. Let's say 30. And now X has 30. Now what do? We want to convert this into an integer. What you can do is you can say int of X. Notice the quotes are not there. Another way, a more shortcut way, a more slightly advanced way is put this one right here. Just for the sake of this, I'll execute one at a time. You convert this into int. Now notice, enter a number, let's say 30, let's say run. And if you see what is inside X, it is 30. It doesn't have double quotes. So something I will ask you to kind of keep in mind manually, guys, is input will always take everything as a string, whatever you enter. We need to explicitly, based on our requirements, we need to convert it into either green tea, ginger tea, float, decimal, or other kinds of data structures and things like that. Everybody with me, guys? Quick yes, please. This is called typecasting or type conversion. Many times we are typecasting, converting this type to that type and things like that, and so on, guys. Okay. Okay, so that is input, and what are we doing with this is referred as typecasting or type conversion. And the same thing again, explaining comma and plus. This is nothing but the concatenation operations is what it is, because we looked at that yesterday. Back to Nescafe coffee, back to a little bit of functions, guys. Functions is probably where you're going to be focusing a lot of time. Functions and a little bit of object-oriented programming. You're going to be focusing a lot of time in a scripting world. So I'll be spending some good amount of time. I'll be kind of stressing you all. So just bear with me while I'm trying to simplify a few concepts for your own good, guys. Okay. If you need specific kinds of concepts also, please feel free to let me know. I'll try to give you examples and help you focus on them. All right. So here is Nescafe. What is special about Nescafe? It's a cup in the park. It's in the global scope. The friendly mantra is it's a cup in the park. By default, everything is in the global scope. Everything is like it is in the park. Now what do? We build functions. Cool. So there is Satya print Nescafe. So there is Satya. Satya as a function is like a house. And what do? You have to go inside this house, which means you need to call this function. When you call, he prints Nescafe. Now, gentlemen, ladies, there is something going on here. Let's see if we can simplify that one. Okay. So come here. We'll choose this one. Nescafe is a cup in the park. So we'll say, we'll put it like this. It's a cup in the park. And what is Satya? Satya is a house in the park. And what is happening is when we say Nescafe, guys, visualize for a moment, he has gone to the park from his house. He's brought the cup inside the house. He's having Nescafe. Okay, so what is happening is you can access a cup in the park. You can get a cup in the park inside your house. Is a friendly mantra. Technical mantra is you can access the global variables inside your house. Inside is what it is. If there are global variables, you can get them inside your house is another way to think of it. That's why there is no problem. We are printing Nescafe, which is nothing but coffee. Okay, but to understand that, let's say, come back here. Back to Ravi's house with a brook bond and a Taj. Now, what is this one? This is the first thing or another thing that we looked at earlier. What is it? This is the opposite of this one. Brook bond, Taj, and Lipton. These are the cups in the house. You are trying to access brook bond. It'll give you an error. You can bring a cup in the park inside your house. But if you try to take a cup in the house to the park, Python will not allow you. Brook bond, Taj, and Lipton are not accessible outside. So that's where we can use return. But for now, I will say you cannot access local variables in the global scope. Everybody with me? Quick yes, please. Okay, so that is something I will ask you. I'm increasing the complexity, guys. You guys need to just kind of bear with me. Together, all these concepts we'll be using when we write some complex scripts and things like that. We'll try to take an example of those things also in the coming up days, guys. Okay. Okay. So Nescafe, and what else we have? Brook Bond. Okay, as simple as that. Now take a look at this. Anuj. Now take a look at this, guys. Come here. Say Nescafe. We have earlier put coffee. No problem. It's in the global scope. It's a cup in the park. But notice what Anuj is doing. Anuj, in his house, he's putting espresso in Nescafe. Let's see what happens. Okay, so what do? You need to call the function, which means you need to go into Anuj's house. Say Anuj. He's printing Nescafe. So it looks like, if you take a look at this one, come back here. Imagine for a moment, the way it looks is, we'll say here is Nescafe. This is in the park. And here is the house of Anuj. And you visualize as if he has taken this cup. Oops. Take this cup inside the house. And originally it had coffee. And now what did he do? He changed it to espresso. Okay. So now, once he is done, visualize for a moment, this cup Python will go back. It'll put it back. And if somebody comes here, oops, they should find espresso here. Because it looks like Anuj has changed Nescafe from coffee to espresso. But let's say come here. If you look at Nescafe, notice it still has coffee. Okay, so there is something slightly different which is going on here, guys. Let's say back to start with Nescafe. It's a cup in the park. So there's a cup in the park. Then come to Anuj's house. And there are a couple of things going on here. Notice when we say Nescafe equals to espresso, notice what is happening is, it looks like, imagine for a moment, he brought the cup in the park. The moment, and when he brings it, he has coffee. The moment he's trying to put espresso inside this one, what is happening is Python is putting it back, putting the cup back in the park. Nescafe will continue to have coffee. And what it is doing is, visualize now, it is creating a new cup called Nescafe inside his house. And what's happening? Espresso is being put there. In other words, when you try to modify global variables inside a function, inside a local scope, or inside your house, Python is not modifying the global variable for now. It is creating a new cup and giving that new cup to you, and it is allowing you to put espresso, cappuccino, whatever you want. So if you print what is in Nescafe, it is printing espresso. Where is it? That's what we're observing. So now if somebody else goes back and sees what is there in the cup in the park, what are they doing? They're observing coffee. In other words, the mantra is, when you're trying to get a global variable, a cup in the park inside your house, when you're trying to get a global variable inside a function, you're accessing, you're modifying it, Python is giving you a new cup. It is not allowing you. For now, I will say, it is not allowing you to modify the global variables inside a function. Everybody catching in that case? That's a slightly tough one. I'm probably going to put a little bit of pressure there. Oops. Sorry about that. 1 moment. Okay, give me a quick yes, guys. Rahul, Shri Sail. Are you able to understand? I'll give you a few more examples. You don't have to get perfect, but just for a quick review, in case any one of you are not okay. But these are slightly advanced and slightly important concepts. You need to some basic stuff, but yet advanced. Not only basic but advanced, but you need to have a good idea, guys. Okay, to be able to do some good, write some good scripting programs or object-oriented programs. These are going to be basic. These are also going to be some advanced concepts you need to keep in mind. So it looks like our thing is, you can get the cup in the park inside your house, but you cannot modify it. You can access the global variables inside your function, but you cannot modify it. If you try to modify it, Python is creating a new cup, is what is happening, guys. Let's try to simplify that. Let's say come back here. Anuj. Okay, so now one more time we'll repeat this. Here is Shilpa. She's saying Nescafe, print Nescafe, no problem. So go into her house. Let's say here is Shilpa. Shilpa, Nescafe continues to have coffee. What is she doing? She's not modifying it. She's just taking the cup. She's just accessing a global variable. The friendly mantra is we are saying we are taking the cup in the park inside Shilpa's house. The technical mantra is we are accessing a global variable, is what it is. Okay. So now, let's say now take a look at this. Here is Vivek. Vivek is another function or a house. He's saying Taj equals to 1 and print Taj. So let's say, come here. No problem. If you say Vivek now, say Vivek, notice no problem. We are printing 1. What is Taj? Taj is a cup in Vivek's house. That is, cup in the house is a local variable. It is in local scope. But take a look at this. Here is Urvashi. Say Brook bond equals to 2 and print Taj. Now notice what happens. What is now? Nothing is happening. Python is not complaining, but you go into her house, which is execute the function. Notice you'll get an error. It is saying Taj is not defined. What is Taj? Taj is some other's cup. It is a cup in other's house. A function cannot directly access the objects inside another function. In other words, your neighbor cannot access your cups in your house. What can a neighbor do? If the same thing, let us say, take a look at this. Here is Urvashi. Say Nescafe, no problem. And we'll call this one Urvashi. Notice no problem. You can get a global variable. You can access a global variable inside function. You cannot access some others local variables. Taj is a cup in Vivek's house. You cannot get the Taj inside Urvashi's house. Catching the point, guys? Everybody with me? Quick yes, please. Cool. Okay. Let's say come back here. Okay, so that is what is the problem. Now Urvashi, so no problem. You said Nescafe. Nescafe is a cup in the park. It's a global variable. You can access the global variables, guys. Back to Krishna. Brook bond is 2. So notice Brook bond is not only in Krishna's house, it is also there in Urvashi. So what is special about it? Inside your own house, you can you create an object, you create a cup, give your own names. That can be the same name. But this Brook bond is different from this Brook bond. This is a cup in Urvashi's house. This is a cup in Krishna's house. This guy is creating Brook bond and Taj. Brook bond is here, used here. Taj is used here. That is not a problem. These will become the new cups. Python is going to create new cups. This Brook bond is not going to refer to this Brook bond or that Taj. Slightly deep one way. So if you now execute this one, Krishna is putting a 2, he's putting a 3, and he's printing a 3. They should not have any problem. Oops, my bad. I need to take this call, guys. Sorry about that. Just give me one moment. Okay, sorry about that, guys. Let's see. Okay, let's go into a little bit more details. And let's say now take a look at this, guys. Say Taj. You can not only access the local variables inside another function, you cannot access a local variable in the global scope. If you're inside another cell, you're in the global scope, you're in the park. If you're in the park, you cannot get a cup. Taj is a cup in Krishna's house. You cannot get that cup outside his house to the park. You can do the reverse. You can take a cup in the park inside the house. You cannot take a cup in the house to the park is something to be kept in mind. Global variables can be accessed inside the function, but local variables cannot be accessed in the global scope is the technical mantra. Okay, cool guys, everybody with me? Because do you think if I share these codes and things like that, you'll be able to access them, you'll be able to execute them step by step, and you'll be able to recall and understand these concepts, guys? Are you feeling comfortable? You think you're okay? Okay. Okay, please feel free to help out yourself. If you're finding it difficult, keep me posted on the day so that I will try to give you a few more pointers and things like that, guys. Okay. So back to Krishna, no problem here. Nescafe is a cup in the park. It's in the global variable. You can access it. The same thing, repetition, probably for sake of discipline, maybe after break and things like that. Okay, no problem here, guys. Okay. Now, gentlemen, ladies, another one time. Rishabh is saying Nescafe equals to cappuccino, but we already know Nescafe is a global variable. It has coffee inside it. That's a cup in the park. Come to Rishabh. And what is his plan? His plan is he wants to put cappuccino. There is coffee, he wants to put cappuccino. But remember, if you take a cup in the park inside Rishabh's house, what is happening? You try to change it, immediately Python will put back this one there, the cup in the park, back in the park, and it will create a new cup called Nescafe, which is inside the house. So this Nescafe is a cup in the house, that Nescafe will be a cup in the park. Catching it, guys? So let's say now, what you do? One more time, say Nescafe, this is a cup in the park. But if you say Rishabh, run it, and it's cappuccino, then again say Nescafe. Notice you'll see coffee. Why? Because the moment you're trying to modify a cup in the park or a global variable, Python is giving you a new cup which is different from the cup in the park. That is why inside the house, it printed cappuccino inside the local scope, but outside in the global scope, we are seeing coffee because this Nescafe is a cup in the park. This Nescafe is a cup in the house. Catching it, guys? Quick yes, please. Cool. Okay. Okay, so now, gentlemen, imagine here comes Rutu. And this time, Rutu, we have just said, Python, when you're trying to modify a cup in the park inside your house, it is creating a new cup. But imagine a scenario where a user or a client, or maybe Rutu, is specifically requesting for that particular cup in the park. She doesn't want to modify the cup in the house. She doesn't want to create a new cup in the house. She wants to get that Nescafe and modify that Nescafe only. So what do you do? Let us see. To start with Nescafe. Come here. Coffee is there, no problem. Now here is Rutu's house. Let's build it. Okay. And now notice what is slightly different is the global Nescafe. When we say global Nescafe, what is the user saying? The user is specifically saying, hey, I want to modify this cup in the park inside my house. It's like she's taking the permission of Python and saying, hey, I don't want you to give me a new cup inside this one. I want to put sunrise coffee inside that. I don't want just coffee. I want sunrise coffee. So what is she doing? She's saying global Nescafe, which means, take a look at this. We'll run Rutu. Run it. And now you see sunrise. And now if you say Nescafe, notice it has sunrise coffee inside it. So what is the catch? You can modify a global variable. You can modify a cup in the park inside your house. What do? You explicitly say global. When you explicitly say global Nescafe, you're taking the permission of Python without taking the permission. So now take a look at this. We already know if you don't take the permission, put a hash. This is without, or in other words, if this is not there. Okay, this Nescafe. So I will call this as no cup. This Nescafe will become a different cup. Python will create a new cup. So when you say global Nescafe, you're explicitly taking a permission, is what it is. You can modify a global variable, a cup in the park inside your house by saying global. Catching it, guys? Quick yes, please. And let's say back to Rutu. Now take a look at this. There's a small catch here. Remove the special characters. Now, if I run this, say, copy this. Let's say run this, no problem. But take a look at this. Global Nescafe. In other words, what is given in 2 lines in the top function, if you just try to declare and initialize in 1 line, it will give you an error. In other words, Python is forcing us. First say global Nescafe, then say Nescafe equals to sunrise. Catching it, guys? So in other words, we should not give it in 1 line. That is more of a syntactical thing to be kept in mind. You have to do it in 2 lines. Catching it, guys? Quick yes, please. Cool. So that is the story of the global variable. So Shruti, this is, we have not given a global. So this will become a new cup. Then now take a look at this, guys. Here is Shilpa, one more time. Nescafe 2 is cappuccino. We do have Nescafe in the part, but we don't have Nescafe 2. So let's see what happens here. So take a look at this. Nescafe 2 has cappuccino, no problem. Nescafe has sunrise. We just earlier, Rutu has filled up sunrise coffee inside that. So we are seeing it. Okay. But let's say, global Nescafe is latte. Okay. Same thing. You say global, you're modifying it to latte. So the global brew. Okay. So now take a look at this, guys. One more time. Let me run Harika. From sunrise, the Nescafe will get modified to latte. If you say what is a Nescafe, you'll see latte inside it. It has modified from sunrise to latte because Harika has said global. When you say global, it's like you're taking the permission of Python and modifying the global variable. Now, let's extend it. Take a look at brew. We have created a cup called Nescafe, but let's see if we have created a cup called brew. It is not created. It is not there in the par. It may be there in somebody else's house, but we cannot access it. So in other words, brew is not there. So what is special is, now take a look at Prabhakar. Here is another function or a house called Prabhakar. What is happening? Global brew. What Prabhakar is doing is, global brew is we are taking the permission of Python. But the cup brew is not there. So what will happen? He's putting cappuccino. So let's say instead of cappuccino, let's put filter coffee inside it. So he's saying global brew. He's asking Python, hey, I want to modify this cup called brew, which is a global variable, which is like a cup in the par. But the cup is really not there. And what is he doing? He's trying to put filter coffee and print brew. So now notice what will happen. Notice it doesn't give you an error. And what is happening is, if you say brew, notice you're seeing filter coffee. In other words, if the cup in the park is not there, inside a function, if you declare something as global, that is actually ending up a cup in the park. You can directly create global variables inside a function. You can directly create a cup in the park from your house, is what it means. Okay, Nescafe, we have explicitly created outside the function, but in this function or in this house, we are creating a brand new global variable inside a function. Are you catching it, guys? Quick yes, please. Cool. Again, that's a slightly deep one, guys, but one moment here. Okay. So come back here. Okay. Oh, one moment. Sorry about that. Pardon me. Put this here. Oops, one more time. Okay, sorry about that, guys. Okay, so short and sweet again, one more time, guys. Inside a function, from a function we can directly create a global variable. And that variable, it is not necessary that the brew is already existing. We are directly creating a cup in the park from our house. It's like, you know, our first step inside the house is we go to the park, we create a new cup called brew, and then you make whatever changes. And if you check it in the park, you will see all the changes that have been made. Is a slightly deep one, guys. Okay. Okay. So sunrise is barista. We're creating another cup called sunrise. Now notice Chandra, global sunrise. This is again the scenario where he's taking the permission. He wants to modify it to Gemini, print it, no problem. A repetition, but just for the sake of digesting this topic, I'm going to run it again. So originally there was barista, and Chandra changed it to Gemini from barista. Quick yes, please. Everybody with me. Cool. Okay. Let's see back here. Let's see what else we have. Cafe. Cafe. Okay. So one more time. Another repetition. Cafe. We don't have a cup. Let's say cafe. We don't have cafe. What you do? Yogesh is directly creating a cafe, which is a global variable. Put coffee inside it. Hopefully, you're following it again. So now if you see what is in cafe, we're accessing it in global scope. We're seeing coffee. And what's special about coffee? Cafe. Cafe is a global variable which was created in a local scope. In a local scope, we can create global variables. A little bit of programmatic jargon is what you need to be familiar and comfortable with, guys. Back to Ritika, again, notice one line. What needs Python is explicitly saying, if you want to modify global variables or cup in the part, don't do it in one line. You need to do it in 2 lines, which is Nescafe. Now it doesn't complain. Okay, guys, hopefully you're getting comfortable. There is Ritika, the same thing. Nescafe coffee. Okay, now take a look at this, guys. One more time. A slight, another permutation and a combination of something you need to be aware of. Nescafe is coffee. Let's put back coffee in our global variable Nescafe. Back to Likita. She's taking the permission Nescafe. She puts latte. No problem. You're taking the permission. So this is going to be the cup in the park, global variable. You print latte. Again, she's taking another permission. If you've taken the permission one time, she's taking the permission second time, and let's see what happens. Notice it's giving an error. In other words, the same thing, put here, put a hash here. Now take a look at this. Okay, now let's call Likita. Let's run it. Notice latte and sunrise. If you see what is in Nescafe now, it has sunrise. In other words, guys, what is happening is she has taken the permission. She has modified latte. She's printing latte. That's what this latte is. You don't need to take the permission again if you want to modify it. You have modified it to latte, then you, for some reason, you change it to another thing. Okay, what you do, you can directly change it. In other words, short and sweet, what I'm saying is, within the same function, you don't need to take the permission multiple times. Every time you're modifying it, you don't need to take a permission. You just take the permission one time. And you can modify it as many times as possible. The catch is you just take the permission one time as the catch of the mantra. Catching the point, guys. Quick yes, please. Okay. And let's see. Print Likita. Okay, one moment here. I'm going to stop the share for one moment here. Let me share these recordings. I think Lakshmi just sent the recordings, guys. I'm going to share the link with you. Give me one moment so that you can practice them back here. See if it's still here. Yes. Let's say there is she. Oh, here we go. Okay. So I'm going to copy this one. I'm going to put this and copy this.
Yes.
Great. Okay. So back to the share zone and back to Jupyter. Back to zone. Sharing the screen, share it. And here's the chat. Okay, here we go, guys. So this is the link where you can find the recordings, guys. Lakshmi has just shared this one. So here is where I'm cool. Actually, and I'm just going to show up myself here, say hello to you. It's me. There's a little bit of introduction going on and things like that. Cool, guys. Ask Python what is. And let's come back here. Okay, guys, everybody got that? Quick yes, please. Okay, thank you, guys. Feel free to review them. Okay, let's see what else we have here. So there is Likita. So what you do, take the permission once, don't take again and again as the mantra or the message. So back to Jayant, he's taking the permission, putting latte. And now what is Wag Bakri here? Oh, here is Likita, taking the permission, modified it. Then she says Wag Bakri. What is Wag Bakri, guys? Jayant is trying to access a cup in Likita's house. What is that? That would be an error. So just for sake of discipline, I'll run this one. Likita, Nescafe, we'll run all these things at one time. Let's run it, Nescafe. Now come here, here's Jayant. Let's see, I think we can define the function, but when you call it, it will complain. So here's Jayant, run it. Notice it says, what is Wag Bakri? In other words, it cannot access that particular cup. Is what it is, guys. Catching it, guys? Everybody getting comfortable? One more time, quick yes, please. Sorry about that. Okay, this will be helpful for you guys. This maybe will be helpful for you. Okay, back to Chandra. Nescafe is a cup. Now notice this, guys. Another combination here. He is first printing Nescafe. He's accessing the cup in the park, a global variable. Then he's taking the permission, and then he's modifying it. So let's see what happens. Let's see what we have in Nescafe. Come down here, come down here, come down here. Here's Nescafe. Nescafe. Latte is there. Now let's go into Chandra's house. And let's say Python is catching it. It is observing before you took the permission, you have already accessed it, you have printed it, you drank the coffee, the latte. Then you're trying to modify it and trying to put hot chocolate into it. In other words, you accessed a global variable, then you're taking the permission and trying to modify it. What you do is, to simplify it, let's say, oops, one more time. Okay, you just take this one, put this here, put this here. Now notice this one, no problem. In other words, if our intention is to modify a global variable or a cup in the park inside our house, by the time you get a little bit of experience of writing the functions and things like that, you'll be able to understand what is an intention there. Okay, when we write a function, we know our intention. Are we going to be modifying any global variable, or are we going to be modifying any local variable? Is what our intentions are going to be. So we'll have an idea. With a little bit of experience, with a little bit of practice, you generally get it. So if your intention is to modify a global variable, first take the permission, then print it, then modify it, then print it. Okay, what are we doing here? We are first printing it. We are first accessing it. And then we are taking it permission. That is what is not being accepted by Python. You are seeing what is inside it without taking the permission and then modifying it. In other words, more precisely, Our intention is to modify it. So don't see it. Okay, if you want to see it, what you do? First take the permission, see what is inside it, then modify it is another way to think of it. In other words, put the global on the top, short and sweet. Whether you're accessing it or whether you're modifying it. If you have taken the permission, even if you do not modify it, also it's okay. There is no problem. Catching the point, guys. Quick yes, please. Cool. Okay. Okay, guys. Let's see. We'll take one or two, and I'll take up wrap up here for today. So back to Chandra, the same thing. Mohammed, Nescafe. Now take a look at this guy. This guy has accessed Nescafe without taking the permission, is modifying it. Who? Without taking the permission is modifying it, and Python doesn't complain. Let's see, Mo, HD Mohammed. Let's run it. It's catching him. He's saying, hey, you are modifying a global variable. And what is the error saying? Before assignment. So kind of, again, that's not a very good error message, guys. But more precisely, his intention is to modify a global variable. What did he do? The first thing is he did not take the permission. If he had taken the permission, where should we take? You take that as the first step, not as the second step. Okay, guys. So different permutations and combinations, just be familiar. So we take the permission, then see what is inside it, put frappe, and then print frappe. Okay, one more time. Nescafe 2. Nescafe 2, you try to see what is in Nescafe 2. It was a cup in somebody else's house. There is no global variable. It's not a cup in a pot. What do you do? Here is wish. He's saying global Nescafe. Global Nescafe 2 means, what is it doing? He's creating a global variable inside a function. And then you're putting Coca Mocha. Okay, see what that is. So he's creating a global variable from inside a function. Say wish. There's Coca Mocha. So you can create global variables inside your function, no problem. If it is not there, it is creating it, it is giving you permission to modify, and then you're able to access. So here is Nescafe 2, sorry. Here is Nescafe 2. There is Coca Mocha. Catching it, guys? Quick yes, please. Okay. So what we'll do, guys, I'll give you a couple of minutes here. Gentlemen, ladies, any questions before we wrap up today, guys? Just type in, if you have no questions, just type in N, guys. Okay. Okay, so I've shared you some of the recordings and things like that. Please have a quick look and a review of these things. And we'll go into some more topics. Hopefully, I'll be taking you into much more interesting topics, and we'll try to get familiar with them, guys. Okay. Okay. If you don't have any questions for today, allow me to wrap up here today, guys. I need to take care of something, so I'm wrapping up 5 minutes early today. Sorry about that. We'll continue the journey from tomorrow and go from there. Everybody okay with that? Can you give me a final yes? Great. Thank you, guys. You guys take care, stay safe, and keep learning, guys. Signing off for today. Thank you and bye for now. Thank you again, guys. Thank you.